Today is Star Review Day 9. We're going to be going over your exponential foldable that is orange. So starting with your exponential functions, remember that your exponential equation is y equals a times b to the x power. Now, your exponential growth and decay formula that's down here says a equals c parentheses 1 plus or minus the rate raised to the time. Now, looking at the first graph that we have here, this graph is going up from left to right. So if you start on the left and go to the right, it's going up. So we call this exponential growth. Now this graph, the second one, if you look at it from the left side to the right side, from left to right, it is going down. We call this exponential decay when it's going down. So the first problem says the population of a small town can be modeled by the exponential function that's given. So here's your equation where t is the number of years after the year 2005. What is the significance of the value of 14,512? So going over this equation that has exponential growth and decay, remember that the c is your start value. The R is your rate, otherwise your percent, known as your percent, and then the T is your time. So looking at this, they're asking us what is the value of 14,512. So I just told you right now that the C value stands for the start. So this is the start value of how many people or the population in this town. So looking at A, there are 14,512 people in the town today. Now, we don't know what today means, meaning is this the year 2001? Is this the year 2005? What does today mean? So here, that just sounds a little bit confusing. B, each year the population increases by 14,512 people. That's not true. It's the starting number. So C, there are 14,512 people in the town in the year 2005. So this is the start value in what year? So if I go back and it says T stands for the number of years after 2005. So yes, this is your start value in the year 2005. So that does make sense. And then D says there will never be more than 14,512. That's not true because if you look at the number inside of the parentheses, it is greater than 1, which means that they added for the rate. So the rate is actually going up, which means it's not going down. So here the answer is C. Problem number 2. At a constant temperature of 15 degrees Celsius, the barometric pressure can be approximated by the formula that's given. So here is our equation where X is the altitude above sea level measured in kilometers. Which of the following statements best describes how the pressure is changing? So they're asking us to look at the rate to figure out is it increasing or is it decreasing? Looking at the number inside of the parentheses, remember that it's always 1 plus or minus the rate. So inside, if this number in my parentheses is greater than 1, that means that it is increasing or it's exponential growth because it's going up. If it's less than 1, that means that they subtracted a number, and this is actually a decrease, which means that it's exponential decay. So here, looking at the number in the parentheses, is it greater than 1 or less than 1? This is considered less than 1, which means it's a decrease. So F says increase, the pressure is increasing, H says decrease, and J says decrease. So right away, cross out F, cross out G. Those two are wrong. So I have H and J. So here it says the pressure is decreasing by 89%, or is it decreasing by 11%? So if you look at the number in the parentheses, 1 minus what number is going to give us 0.89. So if we're trying to figure out this number, is it 89%, which would be 0.89? Would that give me 0.89? Or did they subtract 0.11 to get 0.89? So here, I would actually have to do 1 minus 11% or 1 minus 0.11, and that's how you're going to get the 89. So here, the answer is J. Let's look at number 3. What statement best describes the equation P equals 25 parentheses 1.4 raised to the T if T is measured in months? So the time is in months for this one. So it says initially the p-value is 1.4. The initial value is the number that they start with, which is not 1.4. B says the initial value is 1.4. That's not right as well. C says the initial p-value is 25, and D says it's also 25, so that is correct. Next, is it increasing? Look at both of these. They both say increase. That is correct. It's greater than 1. What are they adding? So 1 plus what is going to give us 1.4. So they added 40%. If you change 40% to a decimal, that would be 0.4. So they're adding 40%. So the answer is D. 1 plus 0.4 or 40% is going to give you 1.4. Problem number 4. A culture starts with 20 bacteria and then it triples every hour. So write an equation for the number of bacteria after T hours. So this goes to our first equation, which is A times B to the X. The reason why I'm not using the one that says C equals the P start value plus 1 raised to the time like that. The reason I'm not using the one with the parentheses 1 plus or minus the rate is because I don't have a rate. I don't have a percentage. I don't know if it's 10%, 20%. There is no percent here. So for this one, we're going to put y equals A as my start value for the bacteria, which is 20, times what is happening to the value. It's tripling, so 3 to the x power. So here, looking at my answer choices, it can't be C or A. If you look at B and D, they both start with 20, and then it's times 3 to the t power or x power. So the answer is B. Problem number 5. Kyle saved $500 from a summer job. He spends 10% of his remaining savings each week. How much will Kyle have after 15 weeks? Notice I have a percent. I have a rate that's given, which means that my equation, I'm going to put my start value, so equals 500, parentheses, 1 either plus or minus. So looking at this, it says that he spends, so that's going to be minus 0.10 because 10% becomes 0.1 raised to the x power, which is your weeks, 15 weeks. So here we have to figure out how much would he have remaining. So we're going to type in our numbers, 500, parentheses, 1 minus 0.1, and then we have to raise it to our time, which is in 15 weeks. So after 15 weeks, he'll have $102.95. So here, the answer is going to be F. Problem number 6. For problem number 6, it says, which of the following represents an exponential function whose initial value is 40, which means that your graph has to start right at 40. So if you're looking at them, I can cross out J because it doesn't start at 40, and the other ones all start at 40. Next, it says that it's growing. So if it's growing, that means that from my graph, I start at 40 and it should be going up. So look at F, that's going down from left to right. H is going up and G is going up. It's growing by 25%. So if I were to write an equation for this, it would be y equals the initial value is 40, parentheses, 1 plus 0.25 to the x power. Now, why is this important? Well, it can help me get another point to figure out if G or H is correct. So let's type in our exponential equation, which is 40 parentheses 1 plus 0.25 raised to the x power. So after I have it typed in, I'm going to pop up a table, Control T, and I need another point that I can determine which graph is correct. So if you look at the first one, it says 0, 40, which we know that it started at 40. So it should also go through 150, 262, and so on. So if I go to 150, 262, I need to figure out which one is going through about 150 and 262. If you look at H and you go to the number 2, that value is nowhere near 62. So look at G. 2 is about 62 because it's between 40 and 80, and 1 is at about 50. So this is going up steadily, and I can look at other points, let's say 497. So at 4, about 97, that is correct too. So yes, these points are way closer than H was. Problem number 7. The graph of y equals 0.91 raised to the x power below models the amount of y of a drug after x hours after it's injected into a patient. What is the y-intercept? So looking at this graph, they're saying that there were 200 milligrams or whatever they're talking about here injected into the patient, and over the course of time the amount of drug remaining is going down in their system. So like if you take a Tylenol, let's say 200 milligrams, the amount in your body is going down as the hours pass. So the y-intercept is the start value. So the start value is 200, so the answer is D. Problem number 8. The graph of y equals 160 parentheses 0.89 raised to the x power represents the milligrams of caffeine y in the body after x hours of drinking an energy drink. So this person has about 160 milligrams in their body, and then you'll notice, because that's 0, the start amount, it goes down. The amount of caffeine in their body is going down after 4 hours, 8 hours, 12 hours, and so on. So here it says, what is the maximum amount of caffeine that's in their body? Well, that would be your start value. What was the starting amount? Right here, right at 0, was 160. That's the most that they would ever have. Now, if you look at the graph, yes, it does continue to go to the left, but that has no meaning in the reference for the problem. That has no meaning in terms of the most caffeine that I could have in the bottle. That doesn't make any sense to have that much, because if the start value is 160, my graph is only going to work from here down. Problem number 9. For problem number 9, it says the graph of y equals 1,350 times 0.72 to the x power is shown below. What is the horizontal asymptote? So the asymptote is the imaginary line that the graph will never dip below. So there's an imaginary line here hovering right on the x-axis. So going horizontal, since it's a horizontal line, that's going to be y equals a number. So looking at my answer choices, I can cross out A. It has to be y equals a number. It goes right through the 0, y at 0. Now, again, remember that this graph does continue to go forever and ever and ever, but it flattens out and it will never dip below that asymptote. Problem number 10. After drinking a can of cola, it says the amount of caffeine in milligrams in a person's body X hours after drinking is given. So here we start with the 0. They have 35 milligrams of caffeine, and then you'll notice that the value continues to decrease. So here it says, find an exponential function that models the amount of caffeine in the body after X hours. So since the start value is 35, we know that it should start about 35, which all of these do. So since I can't tell which of these is correct, we're going to go ahead and get the exact exponential function going through those points. So going to lists and spreadsheets, you're going to type in X and Y, and you're going to type in all of your X's and all of your Y values. After you type them in, remember that you move over to the purple one and you click your X and your Y. After we do that, they told us that this is an exponential function. So by going to menu and analyze graph to regression, looking for the exponential function, I would have to go to 8. So again, that was, I had to go to, if you look at it, I went to menu 4 and then 6, and then I went down to exponential. So menu 4, 6, and then 8, because it says exponential function. So once I get there, I'm going to go ahead and click that. And this is the line that best goes through those points, which is the start value of 35. If you looked at all your answer choices, they all started at about 35. So 35.55, which rounds to 36. And then if you look at your value that it's decreasing by, it's 0.89. So that matches with J. Problem number 11, use a graphing calculator to find an exponential function that best fits the data. So using our calculator, we're going to go ahead and close out what we had from the previous problem, Open up lists and spreadsheets again, and we're going to put X and Y. This time they specifically tell you that you need to use your calculator to get the best trend line. So we're going to go back up here and we're going to type in our X's and Y's. Then we're going to move over to the purple one. Click your X and your Y. And again, menu 4, 6, and show your your exponential function. So here's our exponential equation, which we need to write down because it says use your function, use your equation 722.913. And the more numbers you write, the more accurate your answer will be when you get it. Okay, so the more accurate it'll be to one of these. So once we write down most of those numbers, we have to find the value when X is equal to 15. So here, I'm just going to go to my calculator and I'm going to type in 722.913 parentheses, what we got for our exponential growth or decay inside the parentheses, and then we're going to raise it to, instead of X, after 15. So here I get 567.5, which is going to round to 568. So the answer is B. Problem number 12. What is the domain of the exponential function f of x equals 14 parentheses 0.8 raised to the x? So here we have a graph and your y-axis is the start value, which is right at 14. Since it inside parentheses, it is less than 1, that means that the graph is going down. So remember that your exponential function, it hovers right above the x-axis, although it does continue to go down. So here it's asking for your domain. Remember that your domain is how far left to right your graph is going. If you look for the right-hand side, that graph is going to continue to go forever to the right. It will also continue to push out all the way to the left. So that's going to be all real numbers. And since left to right is your X value, we know that we can cross out A because that's a Y. So the answer is B, all real numbers. Problem number 13. The graph of y equals 2/3 raised to the x is shown below. What is the range of the equation? So range is how far up and down your graph is going. So up and down stands for the y-axis. So that means they're asking for your y values, which I can cross out A. If I'm looking up and down, you can see that the arrow up shows that it continues to go all the way up to hit 100, 1,000, 1,000,000. It continues to positive infinity. But does it continue to go down forever? That answer would be no. Remember that it hovers above this asymptote, the imaginary line. It'll never dip below that. So the lowest it will ever be is really close to 0, but not at 0. So it's all y's above the 0, which makes it D. Problem number 14. For problem number 14, here it's asking you what is the range, which means your y values. If you look, they all have a y for this function. So we're going to go ahead and graph our function in our calculator. It says it starts at 72, and if you look at the exponential growth or decay, it's less than 1, which means that it is going down. It's going to be raised to the x power, and we can have our graph, but I can't see it, so I'm going to zoom out, menu, zoom out, so that I can see my graph. Again, the line is hovering above the x-axis. It never dips below it. So it'll get really close to 0, but never hit 0. So all your y's are above the 0. So to show that, your answer would be D. All y's above 0, above 0. It's going from the y value at 0, your y values are all going up, so it's above. Problem number 15. How would the range of the function y equals 16 parentheses 0.75 raised to the x be affected if it were changed to y equals negative 16 and then still 0.75 to the x power? So here they're saying that you have two equations and you're just comparing the two. So we'll type in the first one, which is 16 times 0.5 raised to the x power. the next one is going to have a negative 16, parentheses, 0.75 raised to the still x power. Okay, so here we have both of our graphs. I'm going to zoom out a little bit so we can see it a little bit better. And you can see your two graphs. The first one, the red one, is the positive 16. And then the one underneath it is the one that has the negative 16. So what they're asking us is how does the range, remember range is how far up and down, how is that affected? Well, if you look at it, the first one are all y's above the zero because that whole graph is above the zero. The next one, if you look up and down, it's all y's below the zero. So here, A says it remains the same. No. B says it changes from y's greater than 16. That's not true. C says that it changes from y's less than 0 to y's greater than 0. That is not true as well. So D, it changes from all the y's above 0, so the whole graph was above the 0, to all y's below the 0. That is true.